So now we're going to shift gears in terms of the statistics that we're doing based off of what we've done so far in terms of the central limit theorem and our work there. We previously we've done statistics and it's been what's called descriptive statistics. We get a sample, we find a sample mean, that tells us something about the sample itself. We haven't been able to go back and talk about our population. We haven't been able to cross this bridge right here, going from, say, talking about a sample mean to a sample, to a population mean. And that's the sort of thing that we want to do. We collect statistics, we do samples, so that we can make conclusions about populations without having to conduct a census, because that's obviously a lot of work and a lot of money. But there are some certain things that we need to do in there. So this is where confidence intervals come in. In this course, we look at two kinds of confidence intervals for a mean, which we'll look at today, and confidence intervals for a proportion, which we're going to look at later on. So just to refresh the central limit theorem, if we've got a distribution x bar n, which is the distribution of all of our sample means, taken from a population x with a mean and a standard deviation that we know by the central limit theorem, when n is sufficiently large, and in this situation we're always going to be working in situations where n is sufficiently large, x bar n is normally distributed with a mean equal to the mean of x, and the standard deviation is sigma divided by square root of n. What this means we can do is we can make a statement. If we've got our mean sitting out here, then there are two values here. We're going to call them negative alpha and alpha, and we'll see what they are in a minute. But we've got 95% of our values are going to sit between these two values. So what that means is we've got our population mean, 95% of our sample means are going to sit within this area. So maybe it's going to be there, or maybe a little bit low, whatever else. Confidence intervals make one small switch to that statement. We're going to swap around x bar and the mean. If we have gone and collected a sample, we have found its sample mean, x bar, we are 95% confident that the true population mean lies within these two values defined by negative alpha and alpha. That's it. That's what our confidence interval tells us. So let's have a look at the formula. We're going to break it down. You do not need to necessarily use this formula. You should be familiar with it. You only need to use it in a test or exam situation when it is very clear that this is what you should be doing. So you'd be filling in some boxes, for example. But there's a couple of things you need to make sure that you get right when writing this out. So look, for a 95% confidence interval, we're making a statement here that the mean, the population mean, and make sure that we're using this notation here, this mu sitting there in the middle, is greater than the sample mean minus 1.96, we'll come back to that in a minute, times the standard deviation over the square root of n. That's coming from, back here, the standard deviation of the sampling distribution. We've basically got the same thing sitting over here on the right, but instead of taking away this 1.96 sigma over root n, we're adding it on. And that's all it is. We're just going to get our sample mean, our standard deviation, and our sample size, plug those values in there and there, and get our values. Now, 9 times out of 10, actually that's not true, but a lot of the time when students do this manually, they make mistakes. Make sure you use your calculator to do this anytime you're asked to find a confidence interval, but if you're asked to fill in some gaps into a formula, put in some boxes, then this is the sort of thing that we'd be expecting to see. Couple of quick notes here. Please make sure you always use mu for that symbol there in the middle. Do not use x bar. It is incorrect. We're making a statement here about the population mean. This is a really simple spot. where if students aren't paying close enough attention, they lose a mark in the exam. Yes, literally 1 mark in the exam if you're doing a confidence interval for a mean, and probably, not certainly, but it'll probably be in there. 1 mark in a 2-mark question for this will be for denoting it as mu. You are warned now. Please do with that information what you will. The other thing, just this 1.96, where is that coming from? It actually comes from the standard normal distribution. So if we've got our Z distribution and we've got the middle 95%, these boundaries are at 1.96 and negative 1.96. That's where those values are coming from. 95% is our standard sort of level of confidence. If we're 95% confident that our mean is within these two values, then there's only a 5% chance that it's not. That's usually enough for us to be okay with making a conclusion. Sometimes we're happier making having a lower level of confidence. So we might only need 80 or 90% confidence. Sometimes we want to be more confident. The reason why we would sometimes go less confident is that will give us a narrower confidence interval. When you get a larger level of confidence, you'll get a wider confidence interval. I like to think about it as a set of soccer goals. The wider your soccer goals are, the more likely you are, the more likely I am at least, to get the soccer ball into the soccer net. Okay? With a wider confidence interval, we're more likely to capture the mean. These are some of the corresponding values. I would suggest make a table of this, put it on your notes page so it's just sitting there just in case you need to bring it out for whatever reason. A couple of really quick notes. If you're given a confidence interval, let's say we're told that the mean heights of students in Stage 2 Maths methods is between 160 and 170 centimetres, then I know the sample mean in that case is right in the middle of that. It'll be 165 centimetres. Okay? And secondly, we can make some conclusions here about the width of the confidence interval. It's just 2 times this margin of error, 1.96 standard deviation over square root of n. And that can be useful. Oftentimes what we do is we flip that around. More commonly, we will write it as we'll want to know what a certain sample size is. So given a standard deviation that somehow we know because we shouldn't have done our confidence interval yet, certainly without the sample size, we want the width to be a certain value. Let's say we want the width to be 10 centimetres. Then we plug those two values into this formula, which is just a rearrangement of this formula here, and we get a sample size that we need. Just be really careful here. If we want the width to be less than something, so let's say we want the width to be less than 10, then we round n up. Okay, we're always going to round this value for n. We're not going to, interview 20.2 people in our sample. We're going to collect a round number. So in that case, it would either be 20 people or 21 people. If we want the width to just be a number, then we'll just round normally. We're not going to do anything funky there. But if we want the width to be less than a value, so we want that width to say be less than 10, then if we plug those numbers in here and we get 20.2, we're going to round that up to 21, and that will give us a width of less than 10. Okay, plug it back into this formula, you would see rounding down to 20, then we would have a width more than 10 in that case. Just one other final point, and you will see this on the formula sheet that you're given as part of the exam. Oftentimes we're collecting a sample to do this, construct this confidence interval, but you'll notice that the confidence interval formula is using the population standard deviation. That's what sigma represents. Often we substitute for the sample standard deviation, which is often denoted as S. Okay, so just be aware of that. oftentimes you're not going to be given any kind of choice about this. It'll just be there's a standard deviation there. It's either the sample standard deviation and you're good to go, or you're subbing it in, or it's a population standard deviation that we've somehow already figured out. This gets really interesting when we start talking about testing some claims. So confidence intervals never give us a definitive answer. So, if I'm talking about the heights of students studying Stage 2 maths methods, I get a confidence interval. Let's say that confidence interval is between 160 and 170. I can't say conclusively that heights are between 160 and 170. If it's a 95% confidence interval, there's a 5% chance that it's not within that range. Even if it's a 99% confidence interval, there's a 1% chance that it's not within that range. So just be careful about making definitive conclusions here. I did speak with a friend or a colleague in another school. He was asking me some questions about some responses and that students had made to a question, and I called him out on the question that he was asking, because his question was about sea level temperatures. The mean value in the 20th century was something. The sample mean taken from the 21st century was another value. I think it was higher than the 20th century. And his question was, have sea level temperatures risen? And in that case, a very suitable answer is, I don't know. Because yes, we can get a confidence interval from that. Yes, a confidence interval may be something where we can support a claim that temperatures have increased, but we can't say that they definitely have, because that's not what confidence intervals do. So look, there's two kinds of claims that we might make. We might make a claim that at a point value. So for example, we might claim the mean is 10. Now, can we support the claim? Can we reject the claim? Be really careful here. And this is something that you need to be careful about. You might hear this. It might be sitting in the textbook still, which if it is, I'm really upset. It might be something that you might hear from colleagues in other schools. It might be something, if you've got a tutor, they might bring out. If you're going to some of the revision workshops or whatever, they might bring this out. But this statement, it's going to feel like a powerful situation that you can bring out anytime. Don't. And this statement is, we can neither support nor reject this claim, and it might be finish off with that 95% confidence or whatever else. Never use that statement. The way that questions in the exam are written, and this will be mirrored in your test, is you will be asked, can you support a claim that is being made, or can you reject a claim that is being made? If you bring out that sentence there, we can neither support nor reject, yes, it might be true, but you're not answering the question. The question is about either supporting or rejecting. Don't talk about the other thing. If the question is, can we support the claim, don't talk about rejecting the claim, is the advice that I'm going to give you here. Let's look at the options that we have here. So, first of all, our claim value is within our confidence interval. So our confidence interval is, we're saying we're 95% confident the mean is between 10 and 20, and our claim is 14. You might feel like we can support that, but we can't support that. This claim is too strong. We're claiming that it's 14, but maybe it's 15. I have no evidence that it is actually 14 and not 15. All I can say is it's between 10 and 20. If I ask you to pick a number between 10 and 20, maybe you'll pick 14, maybe you'll pick 15, maybe you'll pick 19, maybe you'll pick 11.192 or whatever, okay? We cannot support this claim because there are values inside the confidence interval. Really, there are other values inside the confidence interval. Can we reject this claim? No, we can't. And we can't because the claimed value lies inside the confidence interval. Next, if the claim is outside the confidence interval, either above or below, can we support the claim? No. no, we can't support this claim because it's actually the same reason. There are, there are other values inside the confidence interval. We could also say claimed value is outside the confidence interval. That's a really good answer there. Can we reject this claim? Actually, we can. This is the one spot where we can say yes for a point claim. We can actually never support a point claim, but we can certainly reject it. So we can reject it in this case, and we reject it because, actually it's the same value. The claimed value is outside our confidence interval. Gets a little bit more interesting if our claim is an interval, and we'll actually see this a little bit more often in tests and the exam as well. We just need to be, careful here. So let's go through these one by one. You can see that I've got some values here already. So for all of these situations, we've got a confidence interval. It's telling us the true proportion, so the true population mean is between 10 and 20. Now let's say I'm claiming that it's between 12 and 15. Well, this is the same as that point situation. It could be between 12 and 15, but maybe it's 16. That's supported by the confidence interval, but is not in the claim. So we cannot support a claim when the claim lies entirely inside the confidence interval. And it's the same reason we had over here. There are other values inside our confidence interval. We also can't reject our claim. Whoops. Let's change that. We can't reject the claim because, and it's the same reason, the claimed values or the claimed is inside our confidence interval. Just a really quick note, this is another situation where we've got, we can't support the claim and we can't reject the claim. It might feel like you want to bring this statement out here in this situation here, and actually over here as well. Don't fall into that temptation. Answer the question. Can we support the claim? Yes or no? It is literally a yes or no answer, and it will always be a yes or no answer in the questions you get asked. So you always yes or no. And then talk about why we can or can't support or reject that claim. Don't talk about, if the question's asking you can we support the claim, don't talk about rejecting it. Just don't. It's not important, not relevant. Only talk about why we can or cannot support that claim. Okay, situation number 2, we've got a partial overlap. So our confidence interval is between 10 and 20, but we're claiming it's between 8 and 15, or maybe we're claiming it's more than 16. We've actually got very similar answers to what we get when the claim is inside the confidence interval. It's the same reason why we can't support it, because there are other values inside the confidence interval. We can't say that. So in both of those situations, the claim doesn't include 15.5, but that's within our confidence interval. 15.5 is a perfectly legitimate value that maybe it might take. Could we support 15.1? Well, no, it's because there's not enough evidence. But we certainly couldn't. We can't support it because there are some other values inside the confidence interval. Can we reject the claim? Again, no. Part of the claim. So let's say the claim is partially overlaps the confidence interval. We can't reject it because, there are some values in our claim that are not inside the confidence interval, but there are some values in the claim that are inside the confidence interval. It's a sort of complicated situation here. But because there's that partial overlap, we can't support the claim because we've got some values inside the confidence interval. So like over here, this is not, 15, 16, 17 is not inside the claim, but it is in the confidence interval. So we can't support the claim. Can I reject the claim? No, because, everything up to 15 is inside the confidence interval. So we can't support a claim, we can't reject a claim. Go from there. When the confidence interval lies entirely within the claimed range, whether that is we've got a claimed range with two boundaries, or we've got a claimed range that has a single boundary, and that single boundary might be described as less than 25, or it might be has decreased from an initial value of 25, right? It might be described a few different ways. Then in this case, this is the only situation when we can support a claim. Okay, and the reason for that is the confidence interval lies entirely, and here's where we might get a little bit different, within claim. Below 25 in this case might be the situation. It might be like above a number, right? If we're talking about has something increased, have surface temperatures increased, we're claiming that they have. Does it support this? Well, yeah, it maybe does. Okay, try and make sure your answer is in context, that it does refer to the actual values that you're given. So I'd be saying, our claim, confidence interval lies entirely between 5 and 25. Would be a really good answer for that situation there. Okay, try and make it relate to the question you're asked. Of course, if we can support the claim, well, we're not going to be rejecting it, and we've got the same reason here. The claim values and CI, confidence interval, they overlap. Okay, when they overlap, then we're not rejecting it, okay, because it's entirely plausible the true mean is within those values. Finally, if there is no overlap, well, we're not supporting that claim, and that reason is quite simple. It's kind of the same as what we said earlier. There are other values inside the confidence interval, but realistically it's because the confidence interval and claim don't overlap. And you know what? We might actually make this a little bit more contextual. So that means if our claim is we're saying that whatever, it's more than 25, well, our confidence interval is entirely below 25. Okay, there's that context given in that answer, that specificity. It's not just they don't overlap, right? We're specifically talking about the numbers, the intervals that we're seeing here. So while we can't support the claim, we can actually reject this claim. So if the question is asking, can we reject this claim? Yes, we can. Can we support this claim? If that's the question, no, we can't. We're not crossing over. We're not talking about both of those things. We're just talking about can we support it or can we reject it? Can we reject it? Yes, we can, because the confidence interval lies entirely, and I would go above or below whatever your claimed value is. So, in this case, your claimed value, we might say has, we're claiming that it's greater than 25, whatever it is. Our confidence interval is between 10 and 20. Can we reject this claim? Yes, we can, because our confidence interval lies entirely below 25. That's a really good contextual answer there. I'm going to do a quick video to show you how to use your calculator to do this, but this is everything for confidence intervals for a mean.